Functions of the tubule. PCT first. Proximal convoluted tubule. It is lined by the simple cuboidal brush border epithelium, which increases the surface area for reabsorption. Increases surface area of reabsorption. Nearly all of the essential nutrients and the 70 to 80% of the electrolytes and water are reabsorbed by this segment. Are reabsorbed by PCT. PCT also helps to maintain the pH and the ionic balance of the body fluids by selective secretion of hydrogen ions, ammonia, by selective secretion of the hydrogen ions, ammonia, and the potassium ions into the filtrate, and by absorption of bicarbonate ions from it. pH and ionic balance of glucose and amino acids are the reabsorbed by active transport in PCT. Water is reabsorbed by the osmosis. Reabsorption is maximum in the PCT segment. Glucose and amino acids are reabsorbed by active transport in PCT. Water is reabsorbed by osmosis. Reabsorption is maximum in PCT segment. Then next is the Henle's loop. Reabsorption is minimum in ascending limb of Henle loop. This region plays a significant role in the maintenance of highly osmolarity of the medullary interstitial fluid. Descending limb of loop of Henle is permeable to water, but almost impermeable to electrolyte. This concentrates the filtrate as it moves down. The ascending limb is impermeable to water. but allows transport of electrolytes actively or passively. Therefore, as the concentrated filter pass upward, it gets diluted due to the passage of electrolytes of the medullary fluid. Next is the DCT. Conditional reabsorption of the sodium and the water takes place in this segment. DCT is also capable of reabsorption of the bicarbonate and the selective secretion. And selective secretion of hydrogen and potassium ions. Hydrogen and potassium ions. And ammonia to maintain the pH and sodium potassium balance in the body. Next is the collecting duct. It extends from the cortex of the kidney to the inner parts of the medulla. To inner parts of medulla. Large amounts of water could be reabsorbed in this region to produce a concentrated urine. The segment allows passage of small amounts of urea into the medullary interstitium to keep up the osmolarity. It also plays a role in the maintenance of pH and ionic balance of the blood by the selective secretion of the hydrogen and the potassium ions. Mechanism of concentration of the filtrate. The mammalian kidneys possesses special ability for producing a concentrated urine. This special mechanism occurs in loop of Henle and the vasa recta in the medulla region of the kidney. Since the flow of the filtrate in two limbs of loop of Henle is opposite direction, it forms a counter current. This special mechanism occurs in loop of Henle. Special ability for producing concentrated urine. This special mechanism occurs in loop of Henle. Vasa recta in the medulla region of kidney. The flow of blood in the two limbs of vasa recta is also in the opposite direction and therefore forms a counter current. The proximity between the Henle's loop and the vasa recta as well as the counter current in them help in maintaining and increasing osmolality towards the inner medullary interstitium, that is from 300 milliosmolar per liter in the cortex to about the 1200 osmolality per liter in the inner medulla. This gradient is mainly caused by the NaCl and the urea. NaCl is transported by the ascending limb of Henle's loop, which is exchanged with the descending limb of vasa recta. NaCl is returned to medullary interstitial fluid by the ascending portion of vasa recta. Smaller amount of urea enters the thin segment of the ascending limb of Henle's loop. It is transported back to the interstitium by the collecting tubule. This method of transport of substances facilitated by the special arrangement of Henle's loop and vasa recta is called the counter current mechanism. This mechanism